Okay, here we go. So yesterday we talked about adding and subtracting, or adding really, positive and negative numbers using a number line, right? And we used a number line, and it was very easy. I'm going to write a number line because I might need it for just a little while in this course. But, I mean, in this lecture. I guess I should just draw a few little things. So number lines are great. They always work. Always work. The only problem is if the numbers are huge, right? Right? We know that -7 plus a -8 is -7 plus -8 more is going to be -15, right? We know that, right? If on the number line. But if they gave us -463 plus a -762, that would be kind of a bummer to have to solve with the number line. Do you agree with me? I mean, it would take me a very long time. And I would be going, I could do it. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Hey, stop. Oh, wait a minute. Shoot, I lost my place. To start over again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't like the way you're looking at me, Logan. Oh, shoot. Where was I? I got to start over again. Right? It would take you forever. It might take you days. You know, if you were stuck on a desert island, that would be a perfect activity. Give yourself really big numbers, create a gigantic number line in the sand, and you've got something to do, right? But most of us don't have that kind of luxury of time, right? So we got to think of some other way. So as mathematicians, you guys as mathematicians are looking for patterns, right? We're always looking for patterns. That's how math has gone from the caveman to what we do today, to what we know today. We started noticing patterns. So as we look through this, let's start looking for patterns with easy things, and then hopefully we can deduce a pattern that would work for large numbers. So we're going to start with small numbers. So let's try something simple. Let's try 5 minus 1. What is that?
4.
So 1, 2, 3, 4, 5 minus 1. That's 4. Okay. Now, I'm going to just do the reverse. What is 1 minus 5? So 1 minus 5. 1, 2, 3, 4, 5. That's -4. Okay, that's 1. Now let's try another one. Let's try, I don't know. Let's try, how about 11 minus 7? What would that be?
4.
So 4? 11 minus 7. Okay, good. 4. Okay, then let's try this one. 7 minus 11 is -4. So we got to start, we're looking for patterns here, right? Okay, how about, I don't know, how about, I don't know, 8 minus 4?
4.
Oh, that's 4. Oh my God, what's 4 minus 8? Oh, this is so cool. I'm starting to think I'm seeing a pattern. This is really cool. I love this. 10 minus 6, what would that be? 4. Oh my gosh, 6 minus 10 is? -4. This is fabulous. Okay, how about, I don't know, like 9 minus 5? 4. What's 5 minus 9? -4. Oh my gosh. You guys, we might win the Nobel Prize or something. I mean, this is phenomenal. Do you see the pattern I'm seeing? Whenever we add or subtract two numbers together, we either get 4 or -4. I'm sorry? What did you say, Mushy?
You're wrong.
I'm wrong?
Yep.
Dude, look. I know this. I know. Look, all the answers are either 4 or -4. Whenever you add or subtract.
What's
What?
5 minus 6?
Oh, dude, I don't even have to think because I know the pattern. 5 minus 6, that's so easy. 5 minus 6 is 4.
Oh my God!
Sorry, -4. And 6 minus 5 is +4. It is so easy.
Okay.
Dude, that. Well, now wait a minute. There's something wrong with this. Wait a minute. Wait. Give me another one. I think this is, you know what? It just doesn't work with 5 and 6. Okay, so yeah, Gardner.
12 minus 6.
12 minus 6. 12 minus 6 is 4. And 6 minus 12 is negative 4. Oh, wait a minute. Okay, so my theory doesn't work for 12s and 6s and 5s and 6s. But it works for everything else, right?
No. Then why did it work with 9 minus
Okay,
5?
Irene.
17 minus
17 minus 3. Okay, that's 4 for sure.
No,
And then,
no.
oh, wait a minute.
Not.
This is weird. This is weird. So what is the pattern that we're starting to see? So, Jan.
Two numbers with the opposite signs you subtract and gives the number of the greatest absolute value. The symbols.
Okay, say that slower. Say that slower. That was a lot of words.
So if you're adding or subtracting two numbers with different symbols, you subtract them and give them the sign of the greatest absolute value.
Okay. Does anybody else have a different way of wording it? Anybody else? Gardner?
If you have, for example, 1 minus 5,
Yes.
what I do is I flip the problem to 5 minus 1 and then put a negative sign in front of the answer.
Okay. Okay, Rosemary?
The equation is the flip side of the, there's the positive and then you flip the equation and then you have the negative.
Okay. So let me just correct the ones I screwed up on. So we had 6 minus 5, right? Which is 1, and 5 minus 6, which is negative 1. This one was 12 minus 6 is 6, and this is 6 minus 12 is negative 6. And 17 minus 3 is 14, and 3 minus 17 is negative 14. All right. So first of all, do you guys know what absolute value is?
Yes.
How many people do not? Has everybody heard of absolute value? So absolute value. Absolute value of 4. What is the value of absolute?
Positive
4.
That's the positive 4. What is the absolute value of negative 6?
6.
6. What is the absolute value of positive 6?
6.
What's the absolute value of negative 12?
12.
12. What does absolute value mean? Rosemary.
It means, I don't know how to explain.
Okay, Tess.
How far it would be from 0 on a number line?
How far away from 0 on a number line? Notice on a number line, we think of it in terms of integers, right? Integers yesterday. Integers are what again?
Negative numbers.
Positive, negative numbers, positive numbers, negative numbers, and 0. Everything, right? But they have to be whole numbers, technically. But they can be written as fractions, right? But they have to be whole numbers, right? Those are integers. A number line is an integer number line. Do you agree with me? We have positive numbers, 0, negative numbers. But how far is 1, 2, 3, 4, 5? How far is 5 away from 0? It's 1, 2, 3, 4, 5 spaces. It's 5 spaces. So the absolute value of positive 5, how far is 5 away from 0, is positive 5. It's 5 spaces. The absolute value, what about negative 5 though? 1, 2, 3, 4, negative 5. How far is negative 5 away from 0?
5.
It's 1, 2, 3, 4, 5 spaces. So the absolute value of negative 5 is 5 as well. Distance can never be negative. Right? Does it make sense? You cannot have a negative distance. You cannot have a box. Right? There you go. Sorry. This is not a video, right? I should have a real box. You cannot have a box that has a negative distance for a side, right? It's impossible. You can go smaller, smaller, smaller till you get to 0, and then there's no way you can, even imagine having a negative distance. Does that make sense? So absolute value is all about dealing with distances. Okay, it's distance away from 0, basically.
Well, that means that whenever you have a credit card debt, you can just call them and say, "We'll do the absolute value." of my
Right.
credit card
That's a great idea. That's a great idea.
debt."
I like that idea. Why don't you try it? You know, let me know how it works for you. Okay, that's great. So yeah, so what are we noticing? We're noticing that when we have a number and we subtract another number from it. Okay, we have 11 is a larger number and 7 is a smaller number. We take a bigger number, we're subtracting a smaller number from it. We get a positive number, and it's 4. But when we reverse it and we have the same two numbers, only have 7 first, and we subtract the bigger number from it, we get a negative number, but it's the number itself. The sign is different, but the number itself is the same, right? The actual numeral that you're using is the same. That's very cool. So how would that help me when the numbers are huge, right? So how would that help me? So let's say we have 462 minus 845. Is that going to be positive or negative?
Negative.
It's going to be negative. So immediately I write a negative. Now what do I do? Rosemary.
You could add 845 plus 462 and just pop the negative sign in front of it. Oh wait, no, sorry. You could take 845 minus 462.
So would you, yes, right. Would you guys agree with me that this is the difference of two numbers? When you have a subtraction, it's the difference of two numbers. So you still have to find the difference. But it doesn't matter whether I subtract 845 from 462 or subtract 462 from 845, right? But the difference, I have to find the difference. That's what I'm dealing with. So I'm going to hide this negative sign, right? And I'm just going to subtract 462. Right? So that's going to be 3, that's going to be a 7, 14, 8, and then 3, right? So suddenly I know it's going to be negative 383. Has to be negative because I'm taking a bigger number away from the littler number. Does that make sense? All right, so Jan is using very technical terms, which is absolutely accurate. He's saying the absolute value, whenever you subtract two numbers, let's say let's just do something simple. Let's say you have 8 minus 10 equals negative 2. Whenever you subtract two numbers, you take the sign in front of the number that has the largest absolute value. What's the absolute value of 8?
8.
What's the absolute value of negative 10?
10.
10. So 10 is the largest absolute value, right? So the sign in front of the largest absolute value is negative. You with me?
Yeah.
Therefore, I'm going to keep the negative, and then I subtract the largest absolute value minus the smallest absolute value. Does that make sense? Right? It doesn't matter which one you subtract from which. You're going to get the same number. It's just the sign's going to be different. So you keep the sign. But I don't go with the absolute value very often just because I find enough kids get confused by it. It's really easy for me to see that's 8, 10 is bigger than 8. Are you good with me? You follow me? So I'll just say the larger number is 10. I keep the sign in front of the larger number, and then I subtract the smaller number from the bigger number, basically, right? So that's my rule. Right? I don't get as, I like the way you're doing it. I know Matt teaches it really technically, but I just find there's so many kids that it gets too wordy. You know what I mean? But feel free to continue doing it in your words, okay? Because it's totally right. I'm just realizing I probably should start a little further. Rules. Okay, if signs are different. Because that's what we've been talking about. If the signs are different, okay, meaning they're opposite, one's positive, one's negative, keep the sign in front of larger number. Technically, I should be saying larger absolute number with the number with the largest absolute value. The larger number, I'm going to use that for number. Then subtract smaller number from larger. Does that make sense to you guys? Right? Okay, now, what if, so that's rule number 1. Whatever. Here's rule number 2. If signs are different, if signs are the same, sorry. If signs are the same, what do you do? Jan.
Add them and keep the sign.
Okay, add them and keep the sign. Add them and keep the sign.
But there's one way that you need to check the rule,
Yes.
and it's where it's like 4 minus -2.
Yeah.
You change
Correct.
it into a plus.
Right, correct. I was thinking of waiting on that, but I think with this class I can go ahead with it. Because technically you're using multiplication rules, you know what I'm saying? By doing that. And technically, I don't know, maybe I should rethink this through how I do this. Teaching the multiplication first and then doing the addition and subtraction. But anyways, that's a good point. So let's just focus on these first. So I've got 18, negative 18 plus, 7. Negative 18 plus 7. Which is bigger, 18 or 7?
18.
So I'm going to keep that sign of the bigger number. I immediately write that sign. Now I'm going to just subtract the smaller number from the bigger, and I get 11. So it's negative 11. Did you see that? See how easy that is? Right? Yes.
But you said 18, negative 18 is the bigger number, even though 7 is actually a bigger number because it's a positive.
You're right. But technically, you're right. So technically, that's where Jan's terminology is more accurate. The absolute value, which has the bigger absolute value?
Oh.
Negative 18 or 7. Negative 18 has the bigger absolute value. But what I do is I ignore the sign for a second, just because I like to keep it simple. Do you know what I'm saying?
Mm-hmm.
In my everyday life, I just like to say, okay, bigger number 18 versus 7. Okay, what's the sign in front of 18? It's negative. I'm going to keep the negative. But you're right. You're totally 100% right. That's brilliant. Basic.
Or is this about the biggest numbers you're gonna have on the homework tonight, or is there gonna go?
No, they're going to be big. They're going to be big. I mean, not like millions, but there'll be thousands and hundreds and things like that. Just so you can practice. Now, what if the signs are the same? Negative 2 minus 6, right? Think about it. Negative 2, negative 6 more. You're always running to the left because they're both negative, right? So suddenly it's going to be negative 8. Even though you don't use the number line on these, I often do theoretically. And I will often go like this. Negative 2, negative 6. Oh, they're both going in the same direction. I'm going to add the numbers and I'm going to just keep the negative, right? Does that make sense? Sometimes that's really helpful for some people. So anyways, that's it. Fist of 5. Do you guys feel like you understand this?
Yeah.
5, 5, 5, 5, 5, 5, 5. You guys rock. You guys rock. Okay, so I'm going to just stop the lecture. Oh, wait, before I do, I think I'm going to say one thing about what Jan said. Because we might as well, because it technically belongs to this. If you had this, you know how I sometimes write them like this? Positive 5 plus negative 2. That would be 5 minus 2, which is 3, right? But I could do this. Positive 5 minus a negative 2. When you see a negative sign followed by a parenthesis followed by a negative sign, technically that is a multiplication rule because parenthesis always means multiply. And it says negative times negative. And that's where we're going tomorrow. We're going to be talking about that tomorrow, but we might as well talk about it today, this part. Negative times negative is?
Positive.
Positive. That is the weirdest thing I've ever heard, but that is true. Negative times negative is positive, right? Therefore, when you see a negative parenthesis negative, that becomes a big plus sign. So now it's 5 plus 2 is 7. Okay? Does that make sense? You won't see that on the homework tonight, but you'll probably see it on the homework tomorrow night. Okay? Does that make sense? Do you guys see that?
Yes.
So immediately, if I go like this, I have 20 minus a negative 7. It's 20 plus 7, which is 27. Okay? All right. So that is it. Question? Anything? Questions?
I just want to make a comment. So
Yes.
basically, what I think of it as is you can add a little 1 after, so it'll be 20 minus negative 1 times negative 7. Yes.
Oh, I see what you're saying. So he's saying that there's actually a hidden 1 right in front of that parenthesis, and that is true, right? So technically, it's a negative 1 times a negative 7, which is a positive 7. How many people have learned that rule? Negative times negative equals a positive. Have you learned that? Not yet? Daniel, have you? You have?
I have.
Have you? Is there anybody that hasn't learned it before? I'm just curious. So, gosh, this is great. So we can go kind of through this stuff faster, I think. That's awesome. Okay, very cool. So I'm going to stop this. I'm going to let you guys work on the homework.